Hi guys, welcome to another Learn Electronics Repair video. So today I have a parcel that's turned up from Canada, all the way from Canada, and this is a guy named Malcolm, a subscriber, and he says he has about 6 faulty graphics cards, but he sent me 2. So apparently there are 2 graphics cards in this box, and they're not 1060s, they're 1070s. That's what I have, I assume. He said that one of the cards has got a burnt crater in it, and that may not be repairable, but I was welcome to have that as a donor board if I can't fix it. And the other one, hopefully I can repair. So let's get to looking at this. But just before I do open this box, as I've not opened this yet, I have no idea what condition these cards are in. Okay, I don't know if I can fix them, if I cannot fix them, if I have to order parts and ends up being a part 2 of this video. I have no idea what I'm going to find. And that's for some of the new viewers who think that if I can't fix something, then you have to hit dislike. Okay, so I'm just saying, guys, listen, this is reality. Yeah, this may be the only reality electronics repair channel on YouTube, and I can't always fix stuff. Yeah, but what I can assure you is it'll be an interesting video. Okay, so enough said. So let's see if I can actually get into this thing. Yeah, there we go. Let's see if I can get into this thing and let's see what we've got. So I'm assuming 2 graphics cards. And what he's done is, by the looks of it, I've just had a quick glance at it. He sent this one without the fan assembly, and that's okay. I mean, I have said that if it helps reduce the weight and the size of the package, it brings the postage down. You can send me just the card if you like, and I will repair it if I can. But I may well not be able to thoroughly test it. Yeah. Apart from 3080s and such like, which don't seem to even run without the heatsink on, as I have discovered. Anyway, so we have some stickers on this. This one says, "Lots of motherboard beeps, no post does get warm." Okay, so that's that one. And then the other one, which is just the card, "Burn hole under tape." Okay, so that's got a hole in it somewhere. This one's actually got a sticker on, and it's got a part number, but it doesn't say exactly what it is. But I'm assuming it actually is a 1070. And the other one, just dispose of that for a moment. The other one, GeForce GTX 1070 ARM 8GB overclock. I don't know if these are identical or whether they're just similar cards. In fact, I'd say they're probably not identical, because there's a capacitor there and it isn't on this one. Well, it has like a tantalum in the same place. Oh yeah, and this, yeah, they're not identical. We can say they're not identical, I think. So let's get the remaining metalwork off these, and let's have a look first with the microscope. Let's see what we've got here. This one, which is the one with lots of beeps, doesn't post but gets warm. It looks like the warranty seal's never been broken on this, but that doesn't necessarily mean it's never been opened, because obviously the bit of a technique with these is to actually use a pair of pliers and just turn the thing. Yeah, so just because the warranty seal is unbroken doesn't mean that the thing hasn't been opened before. I mean, it could have not been opened before, it could have not been opened before. Okay, so that's that one. Quite dusty, obviously bits of fluff in it and such like. And what's this? What is all this stuff? What do you think, guys? What's all that? Let's get the rest of let's get the other piece of metal off it and let's have a look. Okay, so yeah, it's off. I mean, there's a lot of caked in dust and dirt in this. All the pads seem to be in place, the thermal pads. That all seems to be there, yeah. It's like this stuff's sticky and horrible, yeah. Yuck, yeah. Has this been like... Malk, are you mining with these? Have they been like in a shed or something, maybe? And you know, an environment that isn't really conducive to GPUs. I don't know what this stuff is on it, but the first thing I have to do is get all that off. So I'll try and clean this one. The other one, let's have a look. So this is the one, which again seems to have quite a lot of dust around it, but it's not as bad as that one. And this is the one. What is that a different colour from all the others? Probably just a different phase, I'm guessing. Like this is, yeah, because it has like 4 capacitors. I'm guessing there must be 4 phases for the core, and this is going to be RAM. What's this as well? Let's just initial look around this, but what's that? Not sure. Not sure what that is. Okay, so we can see this one. And this is the one that has the bird mark. So let's have a look first, I think, at this, and let's see what. Let's remove the bandage. This insulting tape. Yeah? Let's remove the insulting tape, and let's see what's under the bandage. Okay. Let's have a look. I see. This looks like the RAM phase is like exploded, or the driver's exploded. Interestingly, this looks like this has got so hot that the solder has melted and the inductor coil has drifted down till it can't move anymore because it hit this one. Because bear in mind, this is this way in the machine, yeah, and this is exploded. So that's what's happened with that one. The other one, yeah, it's just filthy, but let's see if we can get this off here as well. Here we go, that's that out of the way. Yeah. This is just grime. Okay, so what I'm going to do is now, I will say, is I'm going to try and clean these up as best I can, and now let's have a look to see what we've actually got. Okay, so I've cleaned them up with isopropyl alcohol. I mean, I could put them in the sink, but we can have a look around just under the camera first to see if anything obvious that I can spot that requires looking at. I mean, if I spot anything that looks obvious, we can get onto the microscope and have a good look. But that's all. I mean, I've cleaned off whatever it was. It has a few kind of like marks, but most of it's come off. Yeah, I think still was cleaning it up, but obviously I've managed to miss a couple little bits here and there, but nothing that's so bad on it now. Still a bit of crap down in between these as well, obviously, but we've got most of the whatever it was on this. Be interesting, Malcolm, if you can just let us know a little bit about these cars. What environment are they working in, out of interest? If you don't mind just telling us. For everybody's interest, really. Okay. So there's nothing obviously problematic with this. I mean, there could be some small component broken off, maybe that I'm not spotting without the microscope, but it looks fairly reasonable to me. I'm sure you guys will be shouting out at the screen, in which case get into the comments below, yeah, and tell me what I've missed, unless I find it by tracing through, who knows. But yeah, not the most exciting TV, is it? But anyway, look, that's what we've got. I'm sure you're all interested in having a bit of a look around this. Obviously the focus is slightly different at this end, it's raised up a bit. Okay, this is the more interesting, I guess. So I've cleaned this off. It's quite obvious that this has got hot enough to melt solder, yeah. Something's gone here. Some of these capacitors have moved around, look, and this is shifted, yeah. So that's what's happened with that one. But other than that, I don't see any obvious problems again. I mean, that bit where it's burnt, we'll get under the microscope and maybe just have a closer look at that. If even just for the entertainment of it, yeah. Something happened here. What's this? That needs looking at. Okay. Other side. Well, this is underneath the area where where it's burnt. Okay. Nothing as drastically obvious on this side as there was on the other side. No, sorry. I promise not to say that word. Okay. Yeah. Okay. I promise not to say that word so much. All right. Oh, was that bit? Was this just again? This, yeah, it's like a grime that's on these boards. I haven't cleaned this side of it. Right, let's have a look then. So let's get under the microscope. Let's have a look around this area, and let's have a look around this area and just see if we can figure out what's actually happened to this. So this is the area near the bottom edge of the board. It looks like some inductors have gone kind of like walkies here, or possibly vaporized. Something's obviously happened in this area. So that's what we can see down there. And all these L, this, that, and the other obviously should be inductors here. So we can have a look at that. And then this is what's happened up here. So you can see it quite clearly now. This is some sort of dual MOSFET driver, I would think. This is space for another one which isn't there. I'm not sure that was actually ever fitted, but it could have been. And then, no, I mean, I can't imagine that would just disappear to that extent. And then a little jumble of capacitors. Looks like a missile's at this, don't you think? And I'm assuming that's the driver or the controller for it. And this is the RAM phase. Yeah, you can see the coils kind of like come down here somewhere. Okay, so that's what we're faced with. Let's have a look now at the resistances on these boards, and let's see if we can determine if there's any shorts anywhere. So I don't spot any inductor coils on the other side of this, so they're all on this side. So let's start off with the most obvious checks first, which is a 12 volts and 3.3 volt supply coming in. So we've gone to ground, and 12 volts is on the first three fingers up here. And we don't see a short, we're reading 38k. And then the fourth one in here, we're reading 15k. So that's 3.3 and 12. Then obviously we have the other 12 volt coming in here on the bottom or the top of these. One side will be ground anyway. Let's have a quick look. Yeah, so it looks like this is the 12 volts coming in, and then the ground will be on the ones underneath. We can have a look. Yeah, and that looks to me like it comes through a fuse here. So we have a fuse coming in, which reads basically the same both sides. Let's see, is the fuse okay? Yeah, the fuse is okay. My meter's not quite zeroing properly if I zero it, but you can see, just push on the meter lead slightly. So the fuse is okay. Yeah, and then it goes through this inductor coil, I would think. Yeah, it comes out this side of it, that's quite normal. And then goes off into the various circuitry. We have another inductor coil here. Is this on the 12 volts as well? Let's have a quick look. No, it's not. So it's some sort of buck regulator. In fact, there's a controller next to it. So let's look at resistance on this one. No shorts present. This one. No shorts present. This is PEX almost certainly because it's down here, 0.9 volt. Reading 62.7 ohms. That seems reasonable to me. There's another one up here. Maybe 1.8 or 5 volts readings. 16k, that's okay. Don't see any fuses in this area. There's possibly some linear regulator somewhere here, but I don't know. So let's see if we can actually measure V-core on this one. I'll probably get to the end of the one end of these MOSFETs. So it looks like there's two MOSFETs. No, one for each. There's like dual MOSFETs in each one basically. Probably the easiest way to get to these is the back. Yeah, so let's go to the back. And we have, this is core. And we expect it to read low. I mean, it's like, yeah, it's low. That's reading 2.1, is it? 0.9, 0.8. And the short is reading 0.6, yeah. So it's about 0.2. Doesn't surprise me. Probably rated here as well, actually. on these capacitors. So I don't think there's a fault there. It's not a short, it's just a low, very low resistance you'd expect. These up here, this will be RAM. So let's see what RAM's reading on here. Yeah, about 100 ohms, 108. That's quite normal for RAM. So that looks okay on resistances. Let's check a couple of other things. So we need to have a look at the PCIe finger again. So what I want to look at now is effectively the first lane coming in. So it's pins 3 and 4 on this side after the notch. Okay, so it's the 3rd and 4th pin after the notch. And if I put my meter onto diode mode, and you will have seen me do this before. So diode mode. What's on these? So it's reading like a diode, 0.449, yeah, and the other one 0.449. It's the same, which it should be, and there's no short, so that lane is okay. That's the lane, and you see, actually you can see where it comes from. It comes from the GPU. So this is where the GPU is communicating back to the computer, basically telling it what it is. This is when it detects. Other side, on this one, it's not 4 and 3, it's 2 and 3, yeah. So pins 1, 2, and 3. Now, you'd expect them to read different from the other side, but the same as each other. So 806, 806. It's bleeping because I'm just catching the 4th pin, which is ground. 806, 806, and again, the two are not short into each other. Okay, so the lanes are all there. If this has got power and it's reading the BIOS and it's getting anything sensible out of the BIOS, it should be able to communicate back with the computer and detect, assuming the GPU itself is working and it's sending the right data, and obviously a couple other things. Okay, assuming that it's got the V-core power, assuming that the crystal's running, assuming that the reset comes off the GPU, which comes in on one of the pins near this end, I can trace it. Assuming those three things, then it should be able to reply back to the computer with its parameters. So everything looks sort of okay on that. The guy says it gets warm, which makes me think probably the voltages are present. So that's that one. Let's have a look at the other one he sent me. So first of all, again, I'll just zoom. While I'm zoomed in, let's just do these ones so we can go further up and check the voltages. So on this side, pins the 3rd and 4th after the notch. Okay, that reads okay. That reads okay. It reads like the other one did, yeah, and they're not shorted. So this part of the GPU isn't short circuit, I know that much. On the other side, it's the 2nd and 3rd. See 805, 804, and they're not shorted. So that's reading like the other one. Let's see what's on the other voltage rails now on this one. This is PEX, and I think it was about 60 something on the other one. I should have made a note of it. Well, let's have a look. This is what we thought was PEX. Yeah, 56. That reads about the same. So there's no short on PEX. Coming in. About, this is high, much higher than the other cards, 4 or 5 meg. Okay, much higher. 1, 2, 3, 4. 33k, that's similar. So this is reading higher. But it isn't the same board, but you'd expect something similar. 2.8k on that one seems quite reasonable. We have V-core. What's on V-core on this one? Well, that's reading 0.7 or 8. Yeah, this might have a short on the V-core. 1.2. 1.2. 1.2. Why should this one be named differently? 1.1. 0.8. Oh no, maybe not. Maybe there is no short on V-core. This is the interesting one, don't you think, guys? What's on the RAM? Low. But that could be low because of what's happened here. So the first thing I'm going to do with this one is remove this inductor coil. And now let's have a look to see what we've got on the RAM. Just a couple more that I missed. So let's just do this before I remove that one. So ground That's reading almost 1k, 0.9 of a k, 900 ohms. This, I'm guessing, this probably goes to 12 volts. I'll just check it in a minute. Reading about 1 meg, and it's just changing with capacitors charging. 200 odd k on that one. There's like a fuse here. Is this fuse gone? So that's reading 3.5k. 1.5 meg. Is this fuse gone? No, the fuse reads alright. I think my meter's struggling to read because of capacitors that are charging somewhere. So that's like in the kilo ohms and climbing. Mega, that's really... No, they're in the mega ohms, it's my mistake. Okay, that's fine. So the fuse is not gone, and there's no short on the 12 volt coming in. So now I'm going to remove this, and let's see what's going on the RAM phase. I've cleaned that up fairly well, so the coil's off now. When I clean it, I think I managed to lose another bit come off there. I think I lost another SMD component maybe from around here. That doesn't surprise me, yeah. So anyway, the main thing is, what's happening to the resistance on the RAM phase now? This has got a shorted RAM. Okay. So it's almost certainly also has a shorted GPU. I say it's got a shorted RAM. Something shorted on the RAM phase. Doesn't necessarily mean it's a RAM chip. I mean, it could be a capacitor or something for that matter. So I think with this one, let's stick like 1.35 volts into here. In fact, no, let's try the short circuit locator first, and let's see by looking at capacitors around the various RAM chips if I can determine where the lowest resistance is and get some idea where the problem actually is with it. I have the micro ohm meter, so let's see if this will actually tell us where the problem is with this. So this is the capacitors which are right next to the inductor coil. I've removed the inductor coil. Now the first thing I will say is this side of the inductor coil is actually pretty much got a short on it, but that doesn't surprise me because I imagine this is all shorted inside. This side is now disconnected, you know, because I've taken the coil off the board. And here we're reading about 76, yeah, 76.01, yeah. Now let's look at these capacitors. So what's this one reading? 70.8, that's lower. This actually might read a bit lower now because I've got the ground in a different place. 71.1. So this is reading just, yeah, 70.8. Next one. It's a bit higher. Next one's a bit higher. Next one's a bit higher. And all these are next to each other, but this one's reading lower than the others. Just get down to 70.8. Let's have a look now around the RAM chip. So there's capacitors around these. Now I'm assuming that these capacitors, or some of them, will be on the same voltage rail. So I'll just pick a capacitor next to this RAM chip and let's see what I've actually got. So that's reading 73.9. That's higher. You know, yeah, just try and get. We'll try this one. This is reading a little bit higher again. Hang on, there's another one here connecting to by the same chip. So that's a bit higher again. Try this one. A bit higher. A bit higher. Right, let's go around the RAM chips across the top. So we'll just go to this capacitor. 74.9. 74.32. This one. 76.1. And there's just a couple chips left down here. So what are these reading? 75.3. This is by the same one. 79.8. Another one here. Let's see what are these reading. 76.2. So the lowest resistance I can see is this right next to the coil. Yeah. Which makes me think that might be the short, or that this short may well be a capacitor because as I go over around all the RAM chips, I'm reading a higher resistance, but in this area I'm reading the lowest. So I'm going to take this one off and see whether or not that's what it is. Okay, I've taken that off the board. Is the short still here? Let's have a look. Yeah, it is still here. 75 point. It's reading a bit higher though. It is there, 75.3. This one reading 75.6. So it's getting higher. $74.4 there. I don't suppose there's a shorty plane in this board or something. It does seem to me that the problem is basically in this area, and then when I go over to the capacitors, it just reads higher. Yeah. That's probably the ground side of the capacitor, and there's the other side. It actually reads the lowest on that now. That's interesting, because that looks like it's almost like a short circuit plane in the board itself. It's a bit hard to say, guys. I'm seeing the lowest resistance here. Underneath here there's a few capacitors, but I've just had a quick look and I couldn't see a short here. I always see it here. So I think the answer to this now is going to be to stick some voltage in this. I think 1.3 volts, because I mean the RAM probably runs on 1.35 anyway, or even 1.5 depending on the type of RAM. So I'll put 1.35 in here and let's actually see what is warming up on this. I've connected the bench power supply. I've set it to 1.3 volts and I've attached the ground lid here onto the metal frame, if you like. I find it better to just solder a very stiff piece of wire onto the board, something heavy. Some guys like to just use a meter probe connected to the bench power supply and just hold it against the short to inject the voltage, but I like to keep both hands free. I've turned the current on here down quite low, so it's near the minimum. So when I connect this now, I would expect to get very little voltage, which I have in 0.67 of an amp. So I can now increase the current. I'm going to take it up to about 2 amps. And I'm going to see if anything's warming up on this board and where it is. So we have about 2 amps going in there. And you would think that after a little period of time, something would warm up. If it doesn't warm up, I'll actually increase the current a little bit, to a bit higher. At the moment, I don't really feel anything warming up at all. Okay, let's give it a couple of minutes, and if nothing happens, then I'll increase the current. I've had that running for 2 or 3 minutes now. If anything's getting warm at all, and vaguely, it's one of these capacitors. But it's not very noticeable, so I'm going to take the current up some more. Let's put about 3.5 amps into it. Voltage down to 0.8. And again, do I feel anything warming up? There's nothing like getting hot, I can tell you that. But there could be something in this area that's just a little bit warm. It's not the board here. Okay, no, I still don't really see anything. Let's take the current up again. This will go up to 5 amps. So let's just take it up to its maximum. It feels like this RAM chip might be warming up. So I've got the temperature probe, just a thermocouple. Now let's see. So we can just go out by these capacitors first. 32.5, 33.3, slightly 33.4. So that was around the RAM chips. 32.6, 7, 35.1. This one's warmer. That's 35.1. This one's warmer, yeah. That's a little bit cooler again. So look at these other ones. It's 35.6. That was also slightly warmer. 35.0. I can flip with the back of my finger, it's here. Not here. 31 point, 31 point, 31 point, 32, 33, 34. That one, yeah. I can feel it on the back of my finger, guys. This one here is warming up a bit, but it's only warming up a little bit. There's not a lot of heat being generated anywhere. The GPU, it is quite cold. It's nothing in there. It appears to be this one. Yeah. So let's remove this RAM chip and let's see if that gets rid of our short circuit. Well, we can have a look to see if the short's gone now. I mean, the chip's off, and you can see it's nice and clean. I don't think I have any shorted pads together here that would cause you know, a false reading basically. So let's have a look. So this is the end of the stiff wire, and we'll just stick it on ground, and we don't have the short gone away. It's still there. Yeah, we still have a low resistance on here. I think my meter probe's slightly dodgy. I think it's broke here somewhere actually. I'll have to order some more. Well, so injecting voltage isn't getting us very far with this, and the low ohms meter isn't getting very far with this, because the short seems to be basically everywhere. So I think the next thing to do is have a look at a schematic or a board view. I found a board view for this. This is actually an EVGA graphics card, but I found one for the Asus Strix, which is basically the same. I just found one that had the same sort of layout. When I started to look at it, it's basically the same as this. So you'll often find that if you're looking for graphics cards and you can't see a schematic for your exact make or model, have a look at the other ones that are available and see if any of them match yours, and you probably find there are some that are. This is the board view then for the Asus Strix 1070, and it looks like our board. I mean, the layout of the RAM chips is the same. And this is where we had the hole burnt in the board basically. So this is the inductor which I've removed. And you can see that this power rail, this is the 4 capacitors. I removed this one and then I removed this chip, and it's made no difference. And you can see that this supply goes to a lot of places. So it goes to a whole load of pins on the GPU near the center. And it also goes to all the RAM chips. And that's basically where it goes to. So we can see the capacitors it's on, and to be quite honest, if I go to the bottom of this board, so flick it over, it's on a lot of capacitors underneath as well. So you can see it goes to many capacitors, and to start removing these you know, is going to take a lot of work and a lot of time. I'm more inclined to see if the problem is with the RAM or the GPU. While we're in here, we can have a look. So this basically matches the board I have in front of me. These are the capacitors that have kind of like dislodged themselves. This is the thing that's burnt out, which is a yeah, it's a driver basically. It's a driver. But depending on the burning here and the fact we can probably just take these few capacitors off anyway, because there's lots more capacitors, or we may not need all of them. We may be able to do something with this and repair this. The other thing we can see is where this power comes in. So it comes in here, and this is where the beads have vaporized. So we could probably repair this as well. So depending on where the short is, this may be repairable. I mean, I wouldn't say for definite, and certainly if there's a problem with the GPU, it isn't. So I'm going to do something slightly different now. I'm actually going to have a look at this RAM chip, the one we've removed, and see if there's any shorts on the RAM chip. So to do that, I can do it from the actual thing here, to be quite. I can click on the pins and I can see where the power is. I've got this like, let me just click on one of the pins. Yeah, FBVDD, so that's the supply. FBVDD. I can also do this from the data sheet. This is the data sheet for the chip. And you can see the green pins are ground, the reds are the supply. and we can see where they are. We can find this corner. This is pin A1, and the top one is ground, then power, ground, power, and so on. And the same with the middle row on both sides. The top one is ground, and the bottom one is ground. So it really doesn't matter which orientation you put it in. If you go for the middle pin at one end or the other, that's ground, and then you can see below is power, or to the ends. Yeah, so we can find those pins easily. So let's have a look to see if there's any shorts in this RAM chip, the one I've removed. So this is our RAM chip, the one I removed, and we know that on either side the middle pin at the top is ground. So I can get the meter probe onto there. That's ground. I must make sure I'm not shorting to any other pins. Okay, I have it on there, ground. And then basically the second and fourth one down on either end or the middle is power. And we can see that this chip is shorted. Yeah, just got there. Yeah. So this pin is shorted. This is also ground. And that's pin 1A. You can see the little mark. So we know that RAM chip is shorted. So where does that leave us with this? Well, we know that the power goes to all the RAM chips on multiple pins. It also goes to the GPU, sort of around the middle area. So we know that's where it's going to. And we know that one was short. So the chances are quite likely that these are all short, and possibly the GPU as well on that memory supply, VDDQ. The best way to go about this, I think, is to start to just remove all the RAM chips. Maybe just do this side first, and if that doesn't do anything, we'll do this side, and if that doesn't do anything, well, I mean, doesn't do anything, it doesn't get rid of the short, then we'll do these as well. If we still have a short, then I think we'd have to remove the GPU and see, but I'm pretty sure that's where it will be, or it's a capacitor somewhere. There's no point trying to inject voltage into this. I'm getting 5 amps at 1 volt, which is like 5 watts, and it seems to be distributed everywhere. If it was a capacitor, it's going to be one capacitor, and the chances are that would get very hot even before you reach 1 volt. You know, if the voltage here is about 0.5, as I had before, 0.1 or 0.2, not enough to turn any semiconductor junctions on, and that wasn't happening. So all the evidence is that it's all the RAM and may or may not be the GPU. Before I start removing all these, let's just have a look to see if we could get replacement RAM if we wanted, and whether or not it would actually be economical to do so. This is AliExpress, and this is actually the RAM chip. This is one of them. Now, it's given me a price at €12 plus free shipping, and we have 8 on our board. So let's assume not the worst case, because the worst case is a shorted GPU, but let's assume we have 8 faulty RAM chips and we can repair the other damage. So we have €12.07. It's going to be I can tell you now it's 96.54. I can do to my head. Times 8. Oh, okay, I was 2 out. 96.56. Now that's the price, but it says here price includes VAT. And one of the advantages of you guys sending me stuff to repair is that any parts I need, which I buy in the Canary Islands, I automatically get the VAT deducted because it doesn't apply to the Canary Islands. So we can instantly divide this. I get 21% off. So divided by 1.21. So 79, just I say €80, €79.80. That's the cost of replacing all the RAM on this graphics card. Obviously, there's then this problem here, but I think this actually is very repairable, probably easier than you might think. And the reason being, if we look at the board view for this, so we go over to the board view, this is the coil, the one I removed, and it shows here there's 2 driving not MOSFETs, but the drivers. But our board from factory only had 1 fitted. But if you look at the other one, if we click on the one that's where it's burnt up, it's connecting to this, yeah? Same pin. And we can come down here, those are connected together. That's connected, which means we can mount a replacement here and get rid of this altogether. Put the replacement on here, and then what's happening with these capacitors? Well, that end's all connected together. So I can get rid of these 3, or hopefully maybe just 2 of them. I can put 2 here. Is this connected together as well? Yeah, it is. So we can put capacitors here, maybe even be able to put one higher capacitance than the other, and effectively solve the problem. So all this can come off the board, and I can clean up all the sort of like burnt up area. So I think that's more repairable than you might think, or might have thought. This area here, effectively, you can see there's like one big track here, and it comes to one big track here, and it goes through a resistor here by the looks of it. And this, I'm sure, supplies back up into where we were looking. Let's have a quick look. This is going to go somewhere up. I'm sure this is going up into here somewhere. Is there a 12-volt supply that just comes down to everything? Yeah, on there. Yeah, so we can see that. No, actually it doesn't. But I'm sure this here does come up into here somewhere. That may well be ground, actually. Yeah, that's ground. That's the 12-volt supply. Yeah, so you can see. That goes to there, and that's why this is burnt up. And this, I'm certain, is repairable. So this looks to be easier to repair than you might think. This really wouldn't be a problem to repair this. But there's 2 possible flies in the ointment here. One is that I remove all the chips, assuming they are all short. I don't know. I can test each one when I take them off anyway. So one is I remove all the chips and I still have a short, and now I have to remove the GPU, and that's where the short is. That's one big caveat, yeah. The other one is I remove all the chips and the short's gone, but there's damage to the memory controller in here. Now, we can test that. It's a little bit time consuming, but we can do it. So if we get to that point, I can then start measuring in diode mode all the lines that go into the GPU from each chip. I can use the data sheets to do it. You can see all the tracks coming in. And I can measure them all. And if they all read the same, then that's a very strong indication this is okay. If they don't all read the same, that's his shorts on or big differences, then we can say this memory controller is gone. So the next thing then is to remove these. And I did the other one without showing you, but this time I'm actually going to show you on one how to remove it, and then I'll set about removing all of them. To do this, I used 2 things, well, 3 including the tweezers, yeah. So this is a little preheater, Carder 853B. This was quite inexpensive from AliExpress, €40 or something like that. Like everything, they might have gone up a little bit more in recent days or last year or so, but they're not expensive. So I use this, and then I use the Quick 861DW hot air. Hot air set to 450 degrees on full power, and this I kind of like, well, I'll show you what I do with it. So that's what I use. What I don't use or bother with these is putting flux on, because all the balls are underneath anyway. It's not easy to get flux down behind them. I find it just makes the thing more smoky. I don't seem to have any problem doing it this way. I mean, other people can obviously have their opinion. In fact, I mean, you know, there's no harm. We can try some with flux and some without. So if you really want to, you can just get a bit of flux down the sides and hope some of it's going to run underneath the chip. But the other one I removed, I didn't use any flux, so you can see how well that came off. So we can get a bit of that on there. It's going to get a bit smoky, so I don't have a filter here, but what I do have is this thing on, yeah. So this is just a fan, yeah, with a shroud off an old like Dell computer or something like that. And I've attached the thing to a 12-volt power pack, so I can just point this so it blows, effectively blows the smoke away from me. That's all that's really doing. So that's the 3rd thing I'm using, yeah. So we're ready to go now. The other thing I generally do before I start this sort of thing, I don't bother with Captain tape. It's just too much hassle putting it on, and it kind of like hinders you get heat into the board. And if you do this right, you're not going to knock any components out of the way anyway. But what I would suggest you do, as I'm doing now, is just get the phone and just take a photo of the board, so that afterwards you can just examine it and see if you have managed to dislodge any small components. Having a board view, it's not difficult to replace them with the right thing, yeah. So over the preheater, get the chip sort of over the middle of it. If it doesn't balance very well, then I use find a couple of things, I feel like rolls of tape, something just to balance under the edge of it, to so that you can't fall over. Yeah, maybe just find something a little bit better than that. A bit of a lash up, but I just get something under here so we can, let's see, where's the tweezers or something. You can't see what I'm doing. I'm just making sure that this is nicely balanced. In fact, no, it didn't help. Yeah, right, it's balanced. So we got that, and now we start to just heat the board. So preheater's on, heating on, and I don't normally bother with using thermocouples with this. I've had quite a lot of experience doing them, so I'm kind of used to them. So we'll just start to warm the board up a little bit. Okay, that's getting warm now. So what I'll do is I'll take the hot air. I normally use this left-handed, so I've got my right hand for the tweezers, because I'm a bit steady with the right hand, and I need to lift this clean upwards. So we can start warming this up, and once I'm getting some heat in now, I effectively turn the preheater up near to the maximum. So now it's pushing a lot of heat in from the other side as well. And it's just a matter of just warming this up now and taking it off. There's nothing more complicated than that. Get heat directly on it basically. Yeah, it's loose. I messed that one up, yeah, I really messed that one up. But I don't think I actually dislodged any of the capacitors. I just slipped. Okay, now I've got one off, I might as well just move the board and do the other one, because the whole area is quite warm. I'm going to do this one without using the flux. Change hands, and better with the right hand. It's off. That one was much better, yeah, that's how to do it. But I'll leave the first part of the video, you can have a laugh at that anyway. Okay, so those three are off. Preheater off, it's now on blowing on cold air. And I'll just cool the whole thing down, and then let's see. We'll have to clean the solder balls up then. There's blobs all over where I take the chips off, and then let's see what's happened to our short circuit. The board's actually still quite warm, and it's best to do this before it cools down. So we're now going to take flux, and let's get it on here. And I can see straight away I've dislodged one of the capacitors on this one, and I can see where it is. In fact, you can probably see where it is. So the first thing I'm going to just try and do is actually just to lift this off the board, and then we can use the photograph to figure out where it came from. I'll use hot air to get this off, because getting the board warm is going to help anyway when I clean this up in a minute. So let's just see if we can just pick this up. Okay, there you can see on the tweezers we have the one that went walkie, so we can use the photograph from the mobile phone to figure out where that came from. Now it's quite warm, a bit more flux in again on here, and we're going to just clean up the space. So to do this, we just want to make effectively a little ball of solder. I have a BC3 tip, quite a big one. And I can literally just kind of like float this across the chip, yeah, the space. Just like that. Get rid of the excess solder. And that's probably got it. I might have missed an area just here. I'm not putting any pressure on this, I'm just like touching it, yeah. And we'll do the same with the other one, the one that came off much better, which is here. You see, guys, no matter how much experience you have with this, sometimes you just slip, you know, it's just one of them things. But if you take the precautions out, you know, I was doing, make sure that I've got a photograph, then it makes life fairly easy for you, you know, if you do knock something out of the way like that. Okay, so again, some solder, little ball of solder. Obviously, when you're doing this, don't knock off any more little surface mount capacitors nearby. That was clean. Okay, let's clean this up now. Oh, actually, I can still see. Can you see it? I can see it on the screen. Actually, I'm not using the microscope. That would help me. But I can see I've got like a little bridge somewhere here. Yeah, that now appears to be gone. Let's have a look at Lou. Yeah, I think that's okay. I'm going to clean the flux off so I can have a proper look to see what we've got now. That's nice and clean, and I don't have any short circuit between the various balls. It looks nice. Let's have a look to see where this component was knocked off the board. So you can see on my phone, this is the photograph I took. So there's like one here, one here, one here, one here. And if you look at our board, these two are there, and that one's missing, so we know exactly where it came from. This, two things. Firstly, it's almost certainly happened because I put flux on, and it made the thing slippy when I picked it up. Yeah, if I don't put flux on, I really don't do that. Yeah, so that's a good reason to me not to put flux on when you're taking these off. And secondly, that's a perfect example of why you should do this. So rather than having yet another problem, I now have, it's probably so small you can hardly see it. It is in here. Yeah, it's down in here. I know it's in here somewhere. So I have the little capacitor in the bag, and I know where it goes. And I have the board view as well. Yeah, just to prove the point. It's there, yeah, on my finger, yeah. So it's there. So we've got the part, we know where it goes, and we have the board view, so we could have found out what it was. And actually, probably a small capacitor like that probably isn't even essential anyway. So hopefully you can see why I do things these ways. Yeah, perhaps think yourself, maybe that's the best way to go. So anyway, no more messing with this. We've now got rid of 2 more RAM chips. Do we have a short on the board still? Yes, we do still have a short. Let's have a quick look at these 2 RAM chips I've removed and see whether these have shorts on them. This one came off cleanly, and this one's got like a bit of a mess of solder blobs on it. So this one we can check very simply. We just find pin 1 again in the corner, which is here. So top corner is ground, and then I always like to use the black lead to ground, just call it OCD. Top corner is ground, and then second one down here. Yeah, that RAM chip's short. This one, before I can check it, I just need to get rid of this mess on it. This is the one that I actually dropped, and this is the one that had the flux on. Let me just find my flux, one moment. Yeah, there we go. So cleaning this up is the same basically as cleaning up the PCB. Obviously, before I fit new ones, I need to clean the PCB pads with braid to get them nice and flat, ready for the replacements if we get that far. But for now, we can just clean these up. So with this one, same process as before, exactly. Blob of solder, and then sort of float it across the thing, and this will get rid of any big blobs. So blob of solder on there, just gently, that's all. Get rid of that. Same on the other side. These are nice and easy to work with RAM chips. Don't be afraid of removing RAM on a graphics card and replacing it. It's one of the easier things to do actually. Okay, so that one's nice and clean. I won't bother to get the flux off it because I don't need to. Let's find pin 1 again. Actually, I probably do need to because it's got a mess on it. Let me just get rid of the flux off this thing. A bit of ISO. There we go. That's got rid of enough of it so I can actually see what I'm doing. Bit of kitchen roll, essential stuff, kitchen roll. I've mentioned this before, I think the wife always wonders where all the kitchen roll went out the kitchen. Dot in the top corner, can now see it. Now I dropped it. Dot in the top corner, I can see it. So, this one again, we have ground in the top corner. In fact, ground's on the middle, I figured on both ends in the middle there. There's ground. Second one down. So that's short. So that's 3 shorted RAM chips. I think it's extremely likely here we're going to have all the RAM chips shorted. So I'm going to take the other 5 off. I would need to do that anyway, really, to prove, assuming the short isn't still here, that all the address lines and data lines are good. Okay, I'll get these removed. I won't force you to watch it this time. And if I do anything stupid again, you won't get to laugh at me again. Okay, see you in a moment, guys. Here are the remaining 5 of these. Make a bit of space on the board. So here are the remaining 5. Let's have a quick look to see how many of them are actually short. So you can see, as we did before, and I'll just look down the microscope, it's easier for me. That we have. I'm just on resistance range continuity. So middle, any of the middle ones, pin 2. This one appears to be, that's ground. Okay, that one, just get onto it again. That one isn't short. So look at the next one. So again, pin 1 up here, so any of the middle ones is ground. This is also ground. This one's short. So that's a bad one. This one, again, middle. That one's short. This one, middle, short. And the last one, middle, short. So out of all of them, there's only one that isn't short circuit. And you know what? I wouldn't trust that as far as I could throw it into the bin. Okay, so that's that. Here's our board. I managed to dislodge a couple of capacitors up here, which I've stuck back on again. There's 2 actually missing. The other ones came off absolutely fine. Yeah, that's clean. These all came off absolutely fine. So basically, we just have, 2 capacitors there to deal with, and the one that I originally managed. Well, I've actually got the other one I knocked off. Just find out where it was now. Doesn't matter. I can find it from the photographs. It's there. Okay. So there's a $1 million question then. Have we got rid of the short circuit on our board? So without any more suspense, let's have a look. I can do this while it's under the microscope because it was across these capacitors. This is the one I removed, yeah. So what do you think? Place your bets now, guys. 3, 2, 1. And it's gone. Okay, the short is gone. So it was shorted RAM. The question now is whether the memory control of the GPU is good. And I'll just show you how I'm going to do this, and I won't subject you to it because it's quite a time-consuming process. What I'm going to show you now won't definitively tell you if the GPU is good, but it would definitively tell you if the GPU is bad. So we're now going to have a look at the data sheet for the actual RAM chip. Yeah, this is your memory, and you can see here that we have in these like greyish coloured boxes these DQ lines. These are the data with address lines which are attached to the memory controller in the GPU. And you can see they form a pattern. So you got like pins 2, 4, 2, 4 on the top 2 rows. The same to the other side, yeah. Then you miss a couple. Then it's 2, 4, 2, 4 again. 2, 4, 2, 4. And then starting from the other end, it's the same pattern. So it's like a block of 4. You miss 2. There's a square of 4, yeah. A block square with 4. And the same here. And the same here. So we can go around each chip and just have a look to see what we actually have on these pins. And the fact is, they should all actually read the same if the GPU memory controller is good. So we'll go over to the microscope and let's have a look. And this actually, although it's a bit time consuming, you'll see in a minute, it doesn't actually take quite as long as you might think. So I'm connecting the meter to ground. So we know, looking at the first one, we've got like a block of 4. That one, yeah, reading 326. Sorry, that one, this one, and this one, yeah. Then we missed 2 rows, and we got the same pattern again, the same block. This one, this one, this one, and this one. Okay, and then the same will happen from this end of the chip as well. So again, we can go on here. So this is one block. Yeah. Yep. And then we miss 2 rows, then we have it again. See? Yeah. That one. And then the same will happen on this half of the chip as well. So we'll have exactly the same pattern. Repeat it again, and we can once again we can just check them. So 1, 2, 3, 4. Yeah. Miss 2. 1, 2, 3, 4, and the same from the other end. And we've done this chip. So you see, actually, it doesn't really take quite so long. And if you're using the microscope, it's actually quicker. I'm actually using the screen at the moment, which is a bit more awkward, but still. Yeah, that one, got it. Yeah, and so far they're all reading the same. That one, and that one. Okay, and then you miss a block, and the same here. 1, 2, 3, 4. Okay, and that's it. We've done all the blocks on this one, so we know they're all the same. Now you'll also notice that coming from the GPU, there's another load of tracks here as well. You can actually see where they go. Now these will also be control lines or similar coming from the memory controller. So we can look at all these that we can visibly see. And they don't go to the pins we just checked, yeah. And we can look at all these, and we can have a look to see if they're still reading the same, which they are doing. Okay. So again, there's one there, there's one there, and there's one here. So that's all those, and we can do the same on this side. So we'll complete this one chip, and then basically it's just a matter of doing the same with the other chips, yeah. Okay, they're all reading the same. One here, and then we have, well, that's it on that side. So if we repeat that for each of the 8 chips and we read the same on all of them, there's a very, very high probability that this GPU is okay. So I'm just going to do that now, and I'll let you know in a little while how that actually panned out. So guys, I've actually got nothing to report, which is a very good thing because they all read the same. So that's looking like this is probably going to be repairable when actually Malcolm thought he sent me a scrap one for parts. Yeah, we need to have a quick look at these things. ZF906. Let me just see if I find out what this device is and make sure that's available, but we can probably find one of these somewhere for salvageable. But let's have a quick look. This is actually an SIZF906 is the actual part number. Vishay, I believe, is the manufacturer, and I can get like 5 of these for about €9, just under. So we now have a price to repair this. I'm going to speak back with Malcolm. In fact, the first Malcolm's probably going to know about this is when he sees this video, and let's see what he wants to do. If he wants to go to the expensive replacing the RAM plus that part, I mean, we'll need some inductors, but they'll probably cost next to nothing these, so I'm not so much worried about that. So Malcolm, I'm going to prepare you a quote on this one. So that might have actually surprised you, Malcolm, and the rest of you guys watching this. I actually declare this one to be likely to be repairable, depending on if Malcolm wants to accept the quote or not. Okay, so we know what's happening with this one. Let's have a look at the other one now and let's see what we can do with that one. I'll just add that if Malcolm agrees to the quotation on this, that I'll have a go at fixing this VRM first, just to make sure I can get this to run with this bit of sort of cardboard here, but hopefully I'll fit the thing there. Another possibility is if the other one is scrap for some reason, then possibly use the RAM on this one and make 1 out of 2. This one's the ARM GTX 1070 ARM 8G OC, 8 gig overclocked, I'm guessing. So this is the order. It was a long time ago in this video, but you remember I cleaned all like the horrible gunky stuff off this. All the resistance is read okay. So let's plug this one in on the test rig and let's have a look at some voltages on this one and see what it actually does. This is ready to try, so I have the power supply all connected up. It's on the little single channel mining adapter. Always make sure you put this thing the right way around, by the way. That's just one way to instantly trash a graphics card. Okay, so we're ready to go. I've just got my little fan sitting on here on a little thermal pad thing that I have just to give it a little bit of cooling. But I'm just really going to run this long enough to see if we actually have any voltages. I can easily get, I'm on resistance at the moment, you can see the meter. I can easily get to the core because it's on these spaces here where a capacitor would normally go, but in this case doesn't go. Yeah, so I can get V core here and I can get to VRAM on the capacitors over here near to the RAM, because I can't easily get to the coils, but that's not going to be a problem. So we'll switch the power supply on. Let's start this up and see what it actually does. Well, it's spinning. The thing seems to be, oh, you can't see it, but no, it's actually bleeped. Sorry, I'm on ohms range still. Let's just go to voltage. I don't have a picture, by the way. So 0.7, 1.5, just 1.5. So it's definitely got power on the main core. Let's just see if it's actually warming up at all. So I'll just switch that off. So let's stop. Is it getting? Yeah, it's warm. I mean, it's not stupidly hot because I've got this to help cool it down. So this definitely has power getting to it. And I got one bleep out of it. I'm just going to try a different output. Somebody was telling me that some of these graphics cards, not all the outputs work when they first switch on, and they're actually enabled once the drivers load in Windows. So let me just try one of the other outputs. Okay, this one's actually working. I'm getting to the BIOS screen anyway. I mean, this might be due to all that crap I cleaned off it. According to the sender, Malcolm, it doesn't do that. So it's getting to the BIOS basically, or yeah, it might have hung up there as it went into the BIOS. But I was getting a picture. So let's restart. It's just restarted on its own. I have no boot drive on this, but yeah, we're definitely getting that. And then it's saying insert boot drive. Okay, so I'm going to try and boot a drive with this. I'll put the heatsink. Well, actually, it didn't send it to me. I'll try and figure out how I'm actually going to cool this to run it, because I want this running long enough to go into Windows. But it's definitely giving a picture at this point. I've put it together. I've bolted the heatsink back on, because he did send me the heatsink, but no fan assembly. So this is off a scrap pallet. You can see 780 Ti, and I'm hoping that the plug is actually the same. It's a 4-pin connect, so I'm pretty sure these things are standard. So I think I can probably just get this to actually, yeah, just kind of like sit over here. Let's see if I can just wedge it in place. One moment. If not, I can always tie something around it to hold it on. Well, I was going to tie it on with something. I've got it to wedge on there now. So let's see if this powers up, and let's see if we actually get a picture now with it directly in the slot. Well, the fans are running, so that's a good sign. So it bleeps out of it. Yeah, one bleep. Oh, and the blue light's on. Yeah, it's there. Okay, let's attach our hard drive now, and let's see if this will actually load the drivers. Okay, so it's working. It's in Windows. Let's just see if we can get this Windows so you can actually see it. I obviously can't really stress or test this thing because I don't have the proper cooling on it, but I'm sure you can see there it's got 8 gig of RAM. It's there, it knows it's there. I'll just move the get hold of the right mouse. Yeah, GeForce 10 GTX 1070. Yeah, so it's there. This is probably quite an old driver, but it's working. So we can just get rid of that. I mean, just for a second or two, because I do have some, fans on it. Basically, you see, I put some masking tape on there now just to help it a little bit. Let's just see if we can run this just for a few seconds. I don't want to run it very much. Yeah, it's running. Yeah, you can see the temperature down there coming up rapidly, obviously, because there's no proper cooling on there. 103 frames a second. I'm just going to come out of that. So I don't want to be really stressing that without the proper cooler on. But yeah, that one is working. I started this video then explaining that I didn't know what I was going to find once I opened the box, and I didn't. And yet we have this one working. Except I can't stress test it, but the owner also knew that when he asked if he could ship it, to save the bulk of the cost of, the size of the package and the weight. But it's working, and before it wouldn't post, so he tells me. And that appears just to be that horrible sticky stuff that was on there. I have no idea what it was, but seemed to have just stopped it from posting. Possibly just messed up how it was reading the BIOS or something. The other one, surprisingly, appears to be repairable, depending on how he feels about the quotation, which I've prepared and I'm sending. I'll let him watch the video first, and then you can see the good news, and then I'll send the quotation tomorrow morning. Okay guys, I hope you really enjoyed that video. I enjoyed making that one. A little bit long maybe, but it was 2 in 1. And we have 2 more, well, one working and one looks like we can fix it. Alright, see you all soon guys. Have a good weekend. Ciao for now.